Hello everyone, welcome to this video. It's perfect for you if you are starting your journey in data and AI, or if you are preparing for interviews in this field. So let's get started. What if I told you every click you make online is helping companies predict your next move? And no, it's not magic, it's data and AI working behind the scene. Have you ever wondered how companies turn simple data into smart decision? No? Let's understand the complete journey of data inside the modern company. Inside every business, data is constantly being generated from mobile app, website, sensor, and business system. Every click, every purchase, every action becomes data. But here's the catch: raw data is useless. First, this data enters data ingestion gateway, where information from multiple sources is collected. Then it is stored in a data storage, raw data storage layer. But at this stage, data is messy, unorganized, and not ready to use. And messy data led to bad decision. So next comes the cleaning part. Using data integration and transformation, errors are removed, missing values are fixed, and the data is structured properly. And at the same time, data from different sources is combined to create a complete and accurate picture. So now this clean data is stored in a central system called data core or repository. You can think of it as a brain of an entire system, but data alone is not enough. So a knowledge graph and semantic layer add meaning and relationship, helping system understand the context behind the data. Now comes the most important part: using real-time processing engine and predictive analytics. AI analyzes the data to find pattern and even predict future outcomes. So this is where data become intelligence. These insights are then shown in business intelligence dashboard using charts and graphs. So company can clearly understand what is happening. But wait, there is more. At the same time, a governance and compliance engine ensure that all data is secure, private, and follow regulation, because without trust, data is dangerous. All this, all of this comes together in data intelligence platform, where its insight are converted into real business action. And in many cases, AI goes one step further. With automated decision system, decisions are made instantly, like recommending product, detecting fraud, or improving operation. So in simple words, data comes in, get cleaned and processed, turn into insights, and finally become a smart decision. And that's how modern companies use data and AI to grow faster and smarter. Now let's understand the key skills required to become a data professional in 2026. This slide shows a skill map which tells us what area you need to focus on. At the top, we have SQL. This is used to work with databases like fetching and managing data. It is one of the most important basic skill. Next is statistical programming using tools like Python, R. These are used for cleaning data, analyzing it, and building logic. Then comes the machine learning. This help in making prediction like forecasting sales or identifying customer behavior. One of the most important area is probability and statistics. This helps you understand pattern in data and makes correct decision based on logic. We also have data management, which focuses on how data is stored, organized, and kept secure. Another key skill is data visualization or statistical visualization, which means presenting data using chart, graphs, and dashboard so that others can easily understand it. And finally, we have econometrics, econometrics, which means applying maths to forecast financial trends. This chart shows that the data professional need a mix of skills, not just coding, but also statistics, business understanding, visualization. In simple words, to become a strong data professional, you need a balance of technical skills with analytical thinking. I think my thinking spellings get wrong. So let's see what we have on the next slide. Now, let's understand how to choose the right statistical model based on the type of data. This slide is divided into two parts: categorical responses, categorical response and numerical response. And on the left side, we have categorical and numerical predictors. So let's start with the first case. When both predictors and response, predictor and response are categorical, we use chi-square test. This help us if this helps us check if two variables are related or independent. For example, checking if customer types affect the product choice. Core metrics used in this are sum of square observed between deviation between observed and expected frequency. Next, we have next when the predictor is categorical, but the response is numerical, we use t-test. What it does? It compares the mean of a numerical variable between two groups. For example, average sales in region 1 versus region 2. This compares the average value between two groups. For example, comparing sales in two different regions. The core metrics involved in this are t-value, which measures the size of difference relative to the variation in the sample data. Now, if the predictor is numerical and the response is categorical, we often analyze how value differ across groups using method like ANOVA. concept, A and OVA. But mainly, this slide focuses on comparing groups when input varies. When both predictor and response are numerical, we use regression analysis. This helps us understand relationship between variable. For example, predicting house price based on size. This is also one way ANOVA, which is used when we compare average across more than two groups. It helps us understand if there is a significant difference between them. So the main idea of this slide is simple. The type of data decide which statistics method we use, and the key message at the bottom is very important. Before AI predict the future, we must use statistics to understand what is happening right now. So if your foundation in statistics is strong, your data analysis and AI skills will also become more stronger. Okay, now let's see what we have on the next slide. Now let's understand the complete and data analytics life cycle in a simple way. This slide shows that the data analytics is not a straight cycle but a continuous cycle. It starts with problem definition, which means understanding what businesses actually want to solve. Without a clear problem, data has no direction. Next comes the data collection. Here we gather data from different sources like API, databases, or application. After collecting data, we move to data cleaning and preparation. This is where we fix missing value, remove errors, and handle outliers so the data become usable. Okay, then next come the exploratory data analysis, which is called EDA. In this step, we analyze the data to find pattern, trend, and relationship. This helps us understand what is happening in the data. After that, we move to advanced modeling. Here we build algorithm and models to predict, to make prediction or generate insight. And once the analysis is done, we move to visualization, where we present insight using charts, graph, or dashboard others can easily understand. Okay, finally we reach implementation and monitoring, which is at the center of this slide. This is where insights are actually used in real life and the results are continuously tracked. The most important idea here is that this is the loop. After monitoring, we go back, refine the problem, improve the data, and repeat the process. In simple, data analytics is a cycle of learning, improving, the cycle of learning, improving, and making better decision over time. So remember, it is a cyclic process. Here we are going to talk about the different type of data analysis, whether be it descriptive, diagnostic, predictive, and prescriptive, and how they create business value step by step. This slide shows analytics as a staircase, as you can see, where each step takes you higher in value. but also increase the complexity and risk. In first level is descriptive. This answers the question, what happened? Here we look at the past data using report and summaries. For example, the total sales last year or the website traffic. Next step is diagnostic analytics. This answers the questions why it happened. We dig deeper into data to find the root cause. For example, why sales drop in a particular region. After that comes the predictive analysis. Predictive analysis, this answers the question what will happen next. Using machine learning and statistical modeling, we make forecast. For example, predicting future sales or customer behavior. And the final step, we have prescriptive analytics. This answers the question, what should we do? And here, the system suggests action and even optimizes the decision. For example, recommending basic price strategy or marketing plan. So as we move, so as we move up each step, the value to the business increases. As we go up, the value increases. But at the same time, complexity and risk also increases. So that's why the message on this slide is very important. We should not skip step. We should not skip steps. Strong predictive models only work when we have a solid understanding of the past data and the root causes. Okay? In simple word, first understand what happened, then why it happened, then predict what will happen, and finally decide what action to take. I hope you're getting it what I'm trying to say. Now let's understand how modern data and AI systems are evolving step by step. This slide shows a pipeline where each block is represents an important stage in AI powered system. In the first stage, we have storage. This is where all the data is stored. Often in modern systems like lake houses that can handle different type of data such as text, images and videos. Next comes the infrastructure. This is a platform where data is processed and managed. These are the AI ready systems designed to handle large scale data efficiently. The third stage is interaction. Here we work with AI models like LLM, means large language models, which focuses on giving right context so the model understand and responds correctly. After that comes testing. This is where we check how well the system is performing. We evaluate output and improve the system based on result and the final result. And the final stage is augmentation. In this step, we generate synthetic data or enhances existing data to improve model performance and make system more robust. The main message of this slide is very simple, very important, sorry. Earlier, we focuses on only processing raw data, but now the focus has shifted toward understanding the meaning of data in a specific business context, in a precise business context. So in simple word, it's not just about handling data anymore. It's about making AI truly understand and use it intelligently. Okay? Now, let's understand how modern data systems are changing from traditional systems to advanced AI data driven platforms. On the left side, we have a traditional approach where approach where data is stored in separate silos. Text data is stored separately, SQL data are separated, and then media like images, audio, and video are stored separately. This creates a problems like fragmented system, slower performance, fragmented infrastructure, high latency, and data duplication, means duplication of data. In simple word, everything is disconnected and insufficient. Now look at the right side. This is the modern approach called multimodal lakehouse. Here all the type of data, whether text, audio, video, even the 3D data, are stored together in one unified system. This system also support advanced technologies like embedding, which help machine understand data, and fast search method like nearest neighbor indexing, approximate nearest neighbor indexing, and GPU acceleration natively. It also uses GPU acceleration, which makes processing much faster. The biggest advantage is that everything is connected and fast and more efficient. At the bottom, we see the business impact. Because of this modern system, businesses can avoid copying data again and again, reducing delay and performing real-time analysis. For example, you can instantly find similar audio clip from recent data. In simple word, an old system are slow. This one, traditional, is slow and disconnected. But the new system is unified. It is fast and built for AI. Okay? Now, let's understand how modern AI system actually work using context engineering and EDD. What it means? Evaluation driven development. This slide shows a complete flow of how input goes into AI model and how system keeps improving over time. Okay. On the left side, we have input ecosystem. This include system prompt, which guide the AI what to do, dynamic memory, which understand, which help the system remember important information, retrieved data, which brings in relevant external knowledge, and tool output, which comes from other system or APIs. All these input are combined and sent to the LLM, large language model, which are the core of AI model in these days. We don't know about the future. This model processes this information and generate an output. Instead of stopping there, the output is sent to an AI judge or evaluator. This evaluator checks how good the response is. It scores the outputs based on quality, accuracy, and relevance. This is where the evaluation driven development comes in. Instead of guessing or making random improvement, the system uses these scores to improve step by step in a structured and scientific way. This feedback loop then send it to refine prompt, improve context, generate better output over time. The key message is very important. The key message here is very important. Earlier, people used simple prompt engineering, typing everything randomly. But now, the focus is on a structured context. Focus is on structured context and continuous evaluation. In simple word, AI is no longer just about giving prompt. It's about building a system that learns, improves, and become more accurate with every cycle. Now, let's understand how we solve problem of limited data using synthetic data. As you all know, we cannot get data if you are not in a company or preparing a portfolio for the interview or learning it. You can use various type like Kaggle. You can get data from Kaggle, but this is all are clean data, or you can generate synthetic data. This slide explains a very common challenge in the real world. The problem is that the real world data is often limited, unbalanced, or restricted. For example, the rare event like disease doesn't have enough data, and sensitive data is protected by strict privacy rules. Sorry. Because of this, building accurate AI model becomes difficult. To solve this, we use synthetic data. Synthetic data is the artificially generated data created using algorithm, simulation, and advanced model. It looks and behaves like real data, but it does not contain any real personal information. This makes it safe to use, easy to scale. The key idea here is how it works. Algorithm generate data that follow the same pattern and statistical properties as the real world data. So even though data is artificial, it is still useful for training and testing model. One major use case is creating balanced data set. This helps in better model training and also improve the evaluation system like testing and validation. In simple word, when real data is not enough or not safe to use, Synthetic data helps fill the gap. It allows us to build better, safer, or more reliable AI system. Okay, I hope you are getting what I'm trying to say till now. Then look at what is next slide we have. Now, let's understand the final and the most important stage, decision intelligence. This slide shows how data system moves beyond just insight and actually start making decision. At the bottom, we have layer 1, information sources like real-time transaction data, APIs, and unstructured input. These include raw data coming from live systems, cloud, cloud platforms, or different type of inputs. Next, layer 2, AI and analytics model. Here the machine learning and statistical model analyzes the data and generate prediction and pattern. Above is layer 3, decision logic. This is where business rules are applied, constrained, and threshold applied to intelligence. For example, condition like threshold, limit, or company policies are used to guide decision. Then comes the fourth layer, human in the loop. Here, the expert review decision, provide context, and ensure everything is correct and ethical. And finally, at the top is the fifth layer, execution and feedback. This is where the action are taken based on decision and the result is tracked. These results are then sent back into the system to improve future decision. The key message of this slide is very important. Earlier, the business focused on understanding data, but now the focus is on using that understanding, taking decision at scale, taking decision at scale. In simple word, it's not just about insight anymore. It's about making smart decision automatically and continuously improving them. Okay, now let's see next. Now let's understand how we protect data using privacy and compliance practices. This slide shows that the data safe and secure in any systems, AI systems. At the center, the shield represents the protection, which means all data must be handled carefully and securely. First part is privacy by design. Privacy by design, which means privacy are built. Privacy is built into the system from the beginning. We only collect necessary data, take user consent, and control who accesses the data. Next comes the encryption and storage. This ensures that the data is protected both when it is stored and when is being transferred. The techniques like encryption make sure that even if the data is accessed, it cannot be easily understood. The third part, harmonization technique. I hope I am pronouncing it correctly. Here we hide or modify personal information so that the individual cannot be identified. Here is the anonymous part in it. Method like masking and help anonymization. Anonymization helps protect sensitive data. Finally, we have regulation compliance, which means following law and rule related to data privacy. Organization must follow standards to ensure data is handled legally and ethically. The main idea of this slide is simple. Data protection is not optional. Data protection is not optional. It is must. In simple word, strong privacy and compliance practice ensure that data is safe, users are protected, and the trust is maintained. Now, let's understand the role of ethics and culture in building AI systems. At the top, we have the enterprise trust. This means people must trust the system decision, output, and behaviors. This trust is built on three important pillars. First pillar is algorithmic fairness, which means we must make sure that the AI systems does not create bias and discrimination. We need to regularly check the data and model to ensure fair outcome for everyone. Okay. The second pillar is transparency, explainability. The AI system should not be black boxes. We should be able to explain how decisions are made. So even if a non-technical person can understand and trust the result. The third pillar is cultural responsibility. This means that the organization must take responsibility of how AI is used. Leaders should promote ethical practice, teamwork, and the safe way. In the safe way to report issues. The main the main idea here is the AI is not just technology. It's about trust, responsibility, and transparency. In simple word, if the people don't trust your AI, they will not use it, no matter how powerful it is. Okay? Now let's understand why data governance is most important foundation of AI. This slide shows how raw and messy data is transformed into reliable and trustworthy insights. On the left side, we have problem. Data comes in different formats like unstructured data, CSV, it will logs, sensor data, sensor read, no schema, unverified, duplicate, legacy, inconsistency, mixed data. If we use this data directly, it led to wrong insight and unreliable AI result. This is why we need a solution, the universal semantic layer. What is it? This layer acts like a translator and organizer. It gives consistent meaning to data across the entire organization. It ensures that everyone uses the same definition and understand data in a simple way, in the same way. Once data passes through this layer, it becomes structured and reliable. On the right side, we have the outcome. The data become validated, consistent, insecure, audited, and governed. This led to accurate this led to accurate and trustworthy AI insight. At the bottom, we have five key elements of AI governance. First is the semantic data layer, which ensure consistency. The second is transparent validation, which checks data quality. The third is strict access control, which limit who use the data. Fourth is immutable auditability, auditability, which track all changes and actions. And the fifth is proactive risk management, which help prevent issues before they happen. So, without proper governance, AI can give incorrect or risky result. In simple word, clean, controlled, well managed data is a key in building reliable AI systems. Okay, now let's begin. Let's begin everything everything together and understand the complete 2026 enterprise architecture. This slide shows a complete journey of how data analytics, and AI evolves into decision intelligence. At the bottom, we start with analytics maturity curve. First is descriptive analytics, where we understand what happened, then diagnostic analytics, where we understand why it happened. Next, predictive analysis, where we forecast what will happen. And finally, prescriptive analysis, where we decide what action to take. As we move forward, we enter the world of AI engineering. This includes data ops, which manage data pipeline. Here, data pipeline. Model ops, which manage machine learning models. AI ops, which automate and monitor AI systems. Edge AI, which brings intelligence closer to devices. And generative AI, which create new content and insights. All of this, all of this led to the final stage, decision making intelligence. Here everything comes together: data, model, business rule, combined to create system that can make smart decision. These systems include data layer, analytics engine, decision making, optimization system, and actionable intelligence or insight. Throughout this entire process, there is a strong layer of data governance and ethics. This ensures that everything is secure, reliable, and trustworthy. The main idea of this slide is very important. Modern enterprises is not just about using data to understand the past. They are building systems that can actually think, decide, and act. In simple word, this is a complete journey from raw data to intelligent decision making systems. Okay, now let's understand the final message of this entire presentation. A video we have giving it. This slide gives three powerful ideas that every modern organization must follow. First idea is stop at insight, lose the market. This means just analyzing data is not enough. Companies that only create report and dashboard will fall behind. The real value comes when the insights are turn into action and decision automatically. The second idea is engineer for context, not just for scale. Earlier companies focus on collecting more and more data, but now success depends on understanding the meaning of the data in the right context. In the right context, technologies like multimodal platforms or systems, synthetic data, context engineering help AI understand data better, not just processes them. The third is governance, is the accelerator. Many people think governance slows things down, but actually it helps AI grow safely and faster. Strong ethics, data standards, and privacy control build trust and allow system to scale without risk. The final message at the bottom summarizes everything. Turn data into action in a way that is verified, ethical, and fast. In simple words, the future belongs to an organization that doesn't just analyze data but uses it to make smart decision and instant decision. Now let's understand the complete picture of data and AI landscape in 2026. This slide brings together all the important concepts we have learned in a single view. At the center, we have the data and analytic landscape which connect different areas of modern AI systems, modern data systems. On the left, we start with engineering and technology trend. This include multimodal systems that can handle text, audio, video together. Zero copy pipeline for fast processing and vector search for better AI understanding. Below that, we have an AI native data platform This focuses on understanding data using GPU acceleration and combine structured and unstructured data for better insight. Next, the synthetic data generation. This helps in training model when real data is limited and also improve testing and performance. At the bottom left, we see analytical maturity model. It moves from descriptive to diagnostic to predictive and finally prescriptive analytics, showing how businesses grow in this data capabilities. Businesses grow their data capabilities. At the center bottom, we have data analytic lifecycle. This include problem definition, data acquisition, cleaning and preparation, exploratory data analysis, visualization, and implementation and monitoring. On the right side, we have the governance and ethics. This ensures that systems, AI systems, are trustworthy, transparent, fair, and auditable. Below that is the data career framework. It highlights it highlights the important skill like programming, probability and statistics, data visualization, and the roles like data engineering, data scientist, and data analyst. All these components connect together to build a strong data and AI ecosystem. In simple words, success in data and AI comes from combined technologies, skills, processes, and ethics into a one connected system. Okay, that's it in this video. I hope you all understand it. Thank you.